Hello, good afternoon. So yeah, as Tracy said, my name is Martin. Today webinar I will introduce what is Legionella and Legionellosis, some historical outbreaks and confirmed cases of Legionellosis in the past years, the current legislation on Legionella for buildings, the purpose of performing risk assessment, some consideration in design review and visual evaluation, the possible control measures, aspect of operation and maintenance when having to manage Legionella, and a list of references and readings. Legionella is a microorganism that falls under the bacteria category and is naturally present in our environment. Several species of Legionella are existing, and the one of particular interest here is the Legionella pneumophila. These bacteria will grow and develop within a temperature range that is usual to a human environment and optimally at human body temperature. Like for most of bacteria, by heating the water sufficiently high, it will kill Legionella. Legionella bacteria will require three key criteria to be able to grow. Firstly, the presence of liquid and reasonably stagnant water. Secondly, a suitable temperature, typically between 20 and 45 Celsius degree. And lastly, food, such as rust found in corroded carbon steel pipework or other bacteria. Yes, Legionella is able to colonize other bacteria, envelopes, and overgrow them. In addition, biofilm will help bacteria, including Legionella, to grow and develop under a protective layer. Legionella bacteria is a health concern because it can cause legionellosis in humans and could result in severe form of pneumonia called Legionella disease. And there's an example on the screen. The characteristics of legionellosis are summarized in this table. It's important to remember that this is mainly an airborne mode of transmission by water droplets contaminated with active Legionella bacteria. It is not known to be a human-to-human transmission. The incubation period of up to 2 weeks could make difficult the identification of the time and source of exposure. There is generally a good recovery rate, but some persons are more susceptible than others. These are predominantly old men, heavy smokers, drinkers and unfit, as well as persons with a reduced immune system. In buildings, there are particular water systems that will be gathering the condition for Legionella to grow: cooling towers, showers, and wind sprinkler systems. Now that we understand how Legionella bacteria could survive in the environment and be harmful to humans, I will be presenting two historical outbreaks. The first one was in 1976 in a hotel in Philadelphia in the US, where the name of Legionella disease was given to this unknown severe form of pneumonia that affected 221 persons and killed 34. This outbreak was due to the poorly maintained air conditioning system with a cooling tower. The second historical outbreak was in 2002 in an art center managed by a council in Cumbria in England. The persons were infected when walking by the building in a pedestrian alleyway and were breathing contaminated water droplets expelled from the air conditioning unit during the summer period. 172 persons were ill and 7 died from Legionella disease. The initial charges of manslaughter on the responsible person to maintain the building and the council were dropped after 4 years of trial, and they were finally fined under breaking the health and safety regulations. Over the past 7 years, in England and Wales, the number of confirmed Legionella disease cases and deaths remains sadly similar, and with a constant distribution between inland, abroad, and hospital locations. When we look at the population infected, males are the most susceptible, and especially when they age 50 years old and above. Now, looking at other cases of death in the UK, Legionella disease could be perceived as a minor cause. However, over a full year, it still averages 1 case confirmed per day and 1 death every fortnight. We saw the number of cases confirmed in the UK, and in comparison with other European countries, the UK has been in the worst top 3 countries for several years, and it certainly still is, based on the maintained number of confirmed cases over the past 7 years. In addition to exposure category and genders, there is also a seasonal trend of Legionella disease cases increasing during the summer period. This could be explained by the temperature in building water system likely being well within the range of Legionella bacteria to grow, which is 20 to 45 Celsius degrees. Now coming to legislation, Legionella falls under a set of regulations that will be applicable to water systems in building and are mainly related to health and safety in the workplace. The Health and Safety Executive has published a set of guidelines that explain the legal requirements associated to the different water systems in a building. For instance, under the Statutory Instrument 1992, you must notify your local authority if you have a cooling tower or evaporative condenser on site. Also, they published a code of practice, referred as IACOP L8, that presents the minimum required activities that need to be carried out to control and manage the risk of Legionella. So these minimum activities to carry out for an employer or a duty holder of a building are listed here, and they consist of performing a risk assessment, appointing a responsible person, recording the findings and control measures if you have more than 5 employees, notify the presence of cooling towers, as we saw earlier, and any confirmed cases of legionellosis must be reported to the local authorities. Failure to perform or enforce them could result in breaking HSE regulation or being sued for manslaughter in case someone dies from Legionella disease. So it's crucial that a risk assessment is performed for all the water systems in the building and how they are likely to expose occupants, permanent or not, to Legionella. This risk assessment must be carried out by a competent person. This person doesn't need to have a particular qualification or diploma, but must have sufficient knowledge in the risk associated with Legionella, educated to understand what could happen, has attended some form of training, formal or informal, and has some experience in performing risk assessment within water systems in building. A risk assessment is a snapshot of a system at a given time and therefore is valid only at this time. Any changes or modification to the building utilization, operation, water system configuration, or applicable legislation will require the risk assessment to be updated. Strange enough, it's not mandated that a record of this risk assessment is kept. However, any findings or control measures to put in place must be recorded, and this is mandatory if your organization has more than 5 employees. Now, if you are facing charges in court related to Legionella by HSE, it's important to understand that you'll be considered guilty until proven otherwise, which is the opposite in criminal law, where we assume you are unguilty until you prove otherwise. And if you are unable to provide evidence that you did everything practical and reasonable to mitigate the risk of Legionella, you will be in serious trouble and at risk of paying expensive fees. Therefore, BSRIA has produced 2 guides to help building owners, duty holders, facility manager and operation and maintenance team to comply with the legislation. The first one is BG 57, is providing step-by-step process to plan and perform risk assessment in buildings, such as plant, and gives pro forma and condition survey checklist for the most critical assets. The second one is BG 58, is providing a framework to operate and maintain water system to Legionella risk, and provide some pro forma of logbook to keep record in compliance with the legislation. These 2 guides are free to download from BSRIA website for all our members. We now have covered the basis of Legionella bacteria, its health concern and the legislation associated to it. It's time to go through the design and review of some water systems. The examples are simple. They are focusing on bathroom and shower rooms. On the schematic, the red lines represent the hot water supply, the blue lines the cold water supply, and the green lines represent the mix of hot and cold water by the thermostatic mixing valves, TMV. However, these green lines are potential dead legs if no one uses the tap, basin or bath, and could be ideal conditions for bacteria, and particularly Legionella, to develop. Just to clarify, a dead leg is any piece of pipe terminated by a valve or fitting where the flow is halted. This is different from a dead end, which corresponds to a piece of pipe that is capped. So, by reducing a dead leg, the length of the pipework between the TMV and the tap, this reduces the length of a dead leg and available space for bacteria to grow. However, if not used, the incoming flow of cold and hot water are themselves possible dead legs. Therefore, recirculating the hot water will reduce the risk of warm water stagnation in the hot water pipework. However, installation of tight angles and use of high flow velocity could lead to failure by erosion and leaks over time, and this is particularly affect hot water systems. Finally, in large buildings with a central domestic hot water supply, you may need balancing valves to ensure the flow of water can meet the demand by the user. Now on this schematic, we got multiple showers fitted with TMV, and they are a common source of dead legs and therefore high risk for bacteria to develop. Particularly in communal shower rooms of stadiums or school, when they could have extended period of non-occupancy or no activity, for instance during school half-term or summer holidays. The thermostatic mixing valve is feeding several shower heads. Some of them may not be used as frequently as others, creating a possible reservoir of bacteria locally for a particular set of shower heads. So it might be worth reconsidering the design to reduce the length of possible dead legs by introducing individual control and installing TMV at each shower head. With this solution, there is obviously a capital cost, as well as operation and maintenance cost for installing and servicing all this TMV. And this should be assessed against the risk of infecting occupants with Legionella and being sued for manslaughter in case they die from a complication of Legionnaires' disease. Once the design is done and the building constructed, commissioned and running, you may have to use a visual approach to assess the risk by walking around the building. The photo on the left side is showing dead legs in a shower room. There are potential reservoirs for bacterial growth and could contaminate the remaining of the circulating water system, and this reservoir would be immune from biocide treatment. The top photo in the middle is a wet fire hose well. This could be a reservoir for bacterial growth and would put at risk the person testing the firefighting system during maintenance. You could note that the risk of contamination in case of fire will be minute, as most of the occupants should have already evacuated the building when the spray of water occurs. The bottom photo in the middle is showing a fountain. The recirculating water contaminated by external sources, like animals and people, could concentrate the level of bacteria if not regularly replenished, and could warm itself during hot water conditions. It generates a continuous spray and mist of water droplets that any passerby could inhale. The top photo on the right-hand side is a thermostatic mixing valve under a sink. There is a relatively short dead leg, and the tap is frequently used, about once every hour on an average day. Therefore, the risk is minimum. The bottom photo on the right is showing an inaccessible bathtub and shower. These are possible reservoirs for bacterial growth, not being accessible for cleaning or maintaining. It is important to understand that the control measures are derived from a risk assessment, and in some buildings, the risk assessment may not identify any risk for Legionella, and therefore no control measure will be required. For instance, a small building where occupants only use cold water directly supplying from the mains, without any water heating or storage facility. Too often, risk assessors forget that the best control measure remains to eliminate the source of a risk altogether. For instance, is the installation of a cooling tower the only solution to cool the air in your building? Do you really need this shower for the cyclist facility to achieve this additional BRIA credit TRA 03? Then, if the risk cannot be entirely eliminated, control measures will be required and could include to maintain the water temperature outside the range for Legionella to grow and proliferate, to maintain continuous circulation of water to make more difficult for biofilms to form on pipework internal surfaces, to select adequate material for the water system that will not particularly provide food for bacteria to grow or biofilms to form. You may want to limit the release of water droplets. Small droplets will stay longer in suspension and increase the risk of exposing people to contaminated water over a longer period of time. It is essential that the water system is kept in a clean and good condition to maintain the water quality required. Water may be sampled and tested for presence of Legionella. Also, suitable water treatment may be put in place to prevent corrosion, such as injecting corrosion inhibitors or limiting bacterial growth by injecting biocide or using filtration or UV light treatment. It is also important to have a management system in place to ensure that these control measures are correctly implemented, and this could be in form of a quality management system such as ISO 9001. During the operation and maintenance of a building, the identified control measure must be implemented. Something as simple as ensuring that the cold water is below 20 degrees and the hot water above 50 degrees by measuring the temperature at outlet, the point of use, and the sentinel checks. It's important to note that during the warm weather condition, the main water supply could exceed 20 degrees, and you will not be able to do much about it. You could ensure that the cleaning of the water system is performed thoroughly by going up to dismantling shower heads to clean and descale them. Also do a regular tour of the building. Check whether some taps, showers are still accessible or used, and if some pipe has been disconnected for some unknown period of time, you might identify an opportunity to remove them. When receiving results from Legionella testing, target low colony forming unit, the CFU, per liter, to prove your system is adequately managed, and take immediate remedial action if it exceeds 1000 CFU per liter. As a comparison, the level for remedial action to be taken is at 10,000 CFU per liter in the US, based on Ronceray publication. Finally, ensure your risk assessment is reviewed regularly and updated as necessary. For instance, the BSRIA Guide BG58 recommends it's done at least every 2 years. This is a summary of the key references for the management of Legionella in building water systems. You may also want to look at other organizations where you could find formal training or more information on Legionella and the prevention of Legionnaire disease. Finally, I would like to make a tribute to my deceased and so missed colleague Reginald Brown, who once said these words: "You can't prevent Legionella bacteria getting into your water system, but what happens after it is up to you." Thank you for listening for this webinar. If you have any question or inquiry related to building services and particularly water system and their management, with or without Legionella application, please contact us at BSRIA, the SCG team. Thank you very much.